Okay, coming to the new this class. Okay, this PPT I'm going to tell you about the one more question. Okay, that is what the how discretization process happens in finite element method. Okay, so this question is also very important. Okay, explain a discretization process in finite element method. Okay, I already told you finite element method is meant what? It is a numerical technique to solve the complex problem. Okay, those problems subject to what? The material boundary condition, that is what? The loading material. Okay, all those things. Okay, that is called as what? Finite element method. Okay, so finite means what? To divide the given element. Okay, small pieces, that pieces are called as an element. Okay, so you have to remember this. Okay, so basic steps involved in FEM is different, and discretization process steps is very different. Okay, so many students, they are confused to write the same in examination. They may write, if they ask discretization process also, they means what? Basic steps. Okay, that is different and this is different. Okay, so discretization process means how you are going to define the element, how you are going to divide the element. Okay, so which element you are going to suitable for this, and what is the node, and what how you are going to denote the node of numbering scheme. This all comes under this discretization process. Okay, so finite element method basic steps in what? How you are going to solve the numerical problem, that comes under what? Basic steps involved in finite element method. Okay, so here this discretization process can be explained in the following 5 types. Okay, so first one is what? Okay, so discretization means what? It means divide the given element into small pieces. Okay, that is called as element. I already explained this in the basic step involved in FEM. Okay, so this can be explained that discretization process of a finite element method. So following 5 stages. Okay, first one is what? Types of element based on given problem, that is a given geometry. Okay, so second one is what? Size of an element, which size you are going to use. Okay, number of an elements. Okay, location of node and node numbering scheme. Okay, these 5 steps you have to write in the discretization process. Okay, whereas the basic steps involved in FEM means that is what? The different, how you are going to solve the numerical problems. Okay, so let me understand in this PPT. This is the first one. Okay, this first one is very very important. So here in this slide I'm going to tell you about the first one. Okay, that is types of element based on the given problem or given geometry. Okay, given plate or whatever. Okay, so here let me understand first what you mean by element. Okay, what you mean by element? Even if you take any problem, if you divide that element into a small pieces, you are going to get the region small pieces, that is called as an element. Okay, so the standard definition of element is what? It is an element is a mathematical relation that defines how the degree of freedom, that is DOF, of a node relate to the next. Okay, if you divide the small pieces, mean you are going to get attached element. Okay, so that element indicate what? How the mathematically it relate to the next element. Okay, and also it will show the degree of freedom, how many degree of freedom will be there from each node. Okay, okay, and that relate to the next element. Okay, so this is the definition of an element. Okay, so these element can be lines, or that is a trusses, beam or area. Okay, 2D or 3D, plate and membranes. Okay, or a solid. Okay, bricks and tetrahedral, that is a 3D axis. Okay, it also relate how the deflection create the stresses. Okay, so type of element used in finite element analysis, and the depending upon the problem type and the analysis requirement. Okay, so the element which are going to use in the ANSYS software, it depend upon not the question, it depend upon how the problem, which type. Okay, and the analysis is required. Okay, depending upon these two, we are going to select the element. Okay, so if you divide the more number of element, you are going to get the more accurate result in the finite element analysis. Okay, you have to remember this. Okay, so I hope you understand this. What do you mean by element? Okay, element is a divided small pieces are called element, or an element is a mathematical relation that define how the degree of freedom of a degree of freedom of a node is relate, or it is a relation having to the next node. Okay, that is called as an element. I shown in the definitions also. Okay, so there are, depending upon the given problem and given analysis, we are going to use, we are going to select the element. Okay, that may be a 1D, 2D, 3D element. Okay, that we are going to study here. Okay, in the ANSYS software we are going to use that for 3 different element. Okay, so the depending upon the various factor, the following are the different element we are going to use. Okay, first one is a 1D element. D means dimensional. Okay, one dimensional element, and the second dimensional element, and third dimensional element, and axisymmetric element. Okay, these are the 4 element we are going to use in the ANSYS software. Okay, let me understand by one what you mean by 1D element, what you mean by 2 dimensional element, what you mean by 3 dimensional element. Okay, so look at here, first let me understand 1D element. Okay, so 1 dimensional element are the suitable for the analysis of only the 1 dimensional element. Okay, so example for 1 dimensional element means bar, trusses, beam, okay, frame, okay, etc. Okay, in this element there are 2 nodes, and at each node 1 degree of freedom is present along the x direction. Okay, you have to remember. Okay, So look at the example here. The bar is subject to a axial load. Consider this is a bar. Okay, here how many nodes are there? One node and two node. U1 stands for displacement, U2 stands for displacement at node number 2. Okay, one end is fixed, another end is axial force. Okay, so this same diagram you are going to show in the what here, the that is what free body diagram. Okay, so just you draw one line, that is a line, that is a line. Here node number 1, node number 2. At node number 1, U1 F1. U1 means what? Force at node number 1, displacement at node number 1, force at 2, for you displacement at 2. Okay, so here node number 1 is fixed, so here that u1 and f1 will become 0 because there is no displacement. Okay, so here what you are going to understand in this ppt is mean that in one dimensional element each node having only 1 degree of freedom. Okay, this is very important, you have to remember. Okay, such element are called as one dimensional element. Okay, let us assume this is a this is like a linear. Okay, so this is a 2 noded linear element. Okay, this is a 3 noded linear element. Why? So in between it is connected. Okay, 1 2 3, and it is a similarly 1 2 3 4, this is a 4 noded cubic element. Okay, these elements are called as what? One dimensional element. Okay, so what are one dimensional element? One dimensional elements are suitable for the only one day analysis problem, and each node having only 1 degree of freedom along the x direction is called as one dimensional element. Examples are bar, beam, trusses, frame. Okay, all those things comes under one dimensional element. Okay, so next one is this 2D element. Okay, these elements are suitable for the analysis of 2D analysis. Okay, such as a plane stress problem and plane strain problem. Okay, these are also called as a plane element. Okay, so here examples are what? Triangle element and quadrilateral element. Okay, so this last sentence is very important. So in this element there are 2 degree of freedom at each node along one is x and y direction. Okay, let us assume this is a 2D diagram. Okay, so triangle element is a 2D diagram, each node having 2 degree of freedom. Okay, here u1 is x and v1 is y direction, u2 v2, v3 u3 v3. Okay, each node having a 2 degree of freedom. Okay, triangular element. Similarly quadrilateral element. Okay, so here 4 points will be there, 4 nodes will be there, 1 2 3 4 along x, that is at node number 1 u1 v1, u2 v2. Okay, u3 v3, u4 v4. Okay, so each node degree of freedom is 2, whereas in 1D element each node having degree of freedom is what? 1. Okay, so here example for triangular element, quadrilateral element. Okay, so you have to remember. Okay, this is about the 2D element. Okay, coming to the 3D element. Okay, so these elements are suitable for the analysis of the 3D analysis problem. They are also called as a solid element. Okay, like prism, tetrahedral element or hexahedral element. Okay, so 3-dimensional objects are called as 3D element. Okay, so this is a tetrahedral element. Okay, so this is a rectangular prism. Okay, prism. So look at the here 3-dimensional object will be there. Okay, solid elements. Okay, these are the two example for 3D element. Okay, that is prism you have to remember, or hexahedral element you have to remember, or rectangular prism also you have to remember. Okay, 3D element. Okay, so these are again 3D element. Okay, this is 7 noded prism, 6 noded prism. Node nothing but what? Connectivity between the two joints. Okay, so these are the two example for the 3D element. Okay, so look at this object. Okay, this diagram. So 2D element examples are triangle, quadrilateral. Okay, 6 noded element, 8 noded element. Okay, these are the 3D element. Okay, 3 axis. Look at the solid elements, and this is a thickness. Okay, so these two, that is the difference between 2D and 3D element. Okay, so the dotted indicate what? The noded element. Okay, next one is again same 3D elements. Again 3D elements are classified into different categories, that is a tetrahedral, penta, hexa, pyramid. Okay, all these three comes under what? 3D element. Just to assume that 3D elements is a solid element. Okay, so whatever that node may be. Okay, so if you look into the solid elements means that it belongs to the 3D element. Okay, so look at this diagram also. Okay, 1D means each node having 1 degree of freedom, 2D means each node having a 2 degree of freedom. Okay, these are the 2D element. 3D also having 3-dimensional object, that is x, y, z. Okay, these are the different images for the differentiate between the 1D, 2D and 3D. Okay, same in 1D element. Okay, actual model is like this. Okay, rod, truss or beams. Okay, 2D element means what? Plane strain and plane stress. Okay, and 3D element means solid element. Okay, so apart from means spring, mass, rigid will be there, this is not required. Okay, so at in the 1D element, 1-dimensional element we are going to feed the length, here the area we are going to get, here the volume we are going to feed. Okay, so this is about that just information about the software. Okay, so look at this is the definition of node and element. Node nothing but what? It is a element plate. If we are going to divide the small pieces, here I divided rectangular 4 pieces. Okay, so each point that is called as a node. Element nothing but what? It is a mathematical relation. It will indicate how the degree of freedom will be there to the next element. That is what? Element, that is small pieces divided element. Okay, coming to the next last one, axisymmetric element. Axisymmetric element wants in triangular 2D. So this is the triangle. If you cut the section means that is what the axisymmetric element. Both the sides should be same. That is similar to the other. That is called as axisymmetric element. Okay. In triangular 2D, so each element is a symmetric. Okay. Both sides should be symmetric with respect to the geometry and loading about the z axis. Okay. Then z axis is called as the axis of the symmetry or the axis of the revolution. Okay. So here the nodal points are I, J, M or R, theta, Z. Some notation going to use. Okay. So here are the some of the example for the axisymmetric element, that is a domed pressure vessel and engine wall stem. Okay, so look at here cylinder. Okay, shaft. Okay, once if you cut the section means you are going to get this both the sides same way. Okay, that is same structure, that is called as the axisymmetric element. Okay, and the stress strain relationship for the axisymmetric is given by, this is very important, sometimes they may ask you 2 more question. Okay, write the stress strain relationship for the axisymmetric problem means you have to write this. Okay, sigma r, sigma z, sigma theta, tau rz. Okay, that shear stress along the r and z direction, which is equal to E divided by 1 plus mu 1 minus 2 mu. Okay, so E stands for what? Young modulus or metal property. Okay, it is symmetry. Okay, so here the one side is symmetry, one side I shown the mark. Okay, so 1 minus mu, here 4 into 4 matrix it is 1 minus mu 0, and here again here the mu 1 minus mu 0, 1 minus mu 0, 1 minus 2m by 2. This is a direct formula. Okay, and shear strain, that is r direction, z direction, theta direction, and gamma x rz. Okay, so they have to remember this, and this side is similar to this. Okay, just if you fold this means you are going to get the same values here. Okay, otherwise you can write mu. Okay, so this is the stress strain relationship for axisymmetric element. Okay, so again the last finally again I will tell you what you mean by node and element. So node nothing but what? Connectivity between the two elements. The pieces are called as an element. Okay, a node is a coordinate location in a space where the degree of freedom is are defined. Okay, so node is nothing but what? It is a point where we are going to define the degree of freedom. How many degree of freedom will be there? Okay, 1 dina, 2 dina, the 2 or 3 whatever. Okay, the degree of freedom for this point represent the possible movement of this point due to the loading of the structure. Okay, in FEA a node may be limited is calculated motion very variety of the reason. Okay, whereas what do you mean by element? Then in finite element analysis you divide your model into a small pieces, those are called as element. Okay, finite element. Okay, those element connect all the characteristics point are called as node. Okay, that lie on their circumference, and the connection is a set of the equation called as shape function. Okay, this shape function we will study in the later. Okay, so this is about the brief introduction about there is a discretization process, the first step. Okay, so in these steps you are going to understand what you mean by 1D element, what you mean by 2D element, what you mean by 3D element, and what you mean by what axisymmetric element. Okay, 1D element means what is the difference, differentiate between 1D element, 2D element, 3D element. Okay, with example. Okay, so I hope you understand the first step of discretization process in FEM. Okay, so in the second step you are going to study again the next further stages 2, 3, 4, 5. Okay, I hope you understand this. Okay, thank you.